Alright, yesterday we looked at solving quadratic equations by graphing. Today what we're going to do is look at more of an algebra way of solving things and just solving equations normally. But the key thing is today's method only works well if it's in Vertex form. If it's in Vertex form, it's a pretty easy process. If not, then you have to convert it to Vertex. So the first thing is, instead of graphing, we could still graph this. You could graph y equals 2x minus 3 squared minus 8, graph it, and we would get our two solutions like we normally would, and that would be it. Find your x and y intercepts, or x-intercepts. The trick though is it's often easier to actually do this mathematically. So what we want to do is you just basically want to rearrange the equation. So normally if you had a normal equation, like if I gave you 2x minus 8 equals 0, we would bring the 8 to the other side and then divide by 2. And that would give us 4 for an answer. So we kind of do the same thing, except we have an x squared, or x minus 3 in this case. You want to get that isolated by itself before you do the square root. Okay, and then once you have it isolated, then you would have your solution once you square root it. So let's actually we'll try an easier one. We'll come back to this one in a second. So here's a pretty easy equation. So we want to get x squared by itself. So if we bring the minus 9 to the other side, so that would give us x squared equals 9. The next step is square root both sides. We get x equals square root of 9 is 3. But we need to remember that we actually get plus and negative 3. Right? Because 3 times 3 is 9, negative 3 times negative 3 is also 9. So we have to do the negative as well. So we can write it shortcut like that, or you could just write it as two different answers, one positive, one negative. So either of those two solutions would be correct. So let's try another one a little bit harder. So in this case, bring the 64 over. So we add 64 to both sides. Then we would divide by 4. So 64 divided by 4 is 16. Square root both sides. So that would give us plus or minus 4 as our answers. So you can see it's a pretty fast, easy way to solve questions. A lot faster than trying to graph. Okay, here's another one where we got brackets, so same thing, just get the brackets isolated. So bring the 49 over to the other side. Now we square root both sides. We'd have x minus 1 equals plus or minus 7. So then our last step is bring the minus 1 over.
Main office, please.
So we'd have plus or minus 7, and then we would add 1. So once you have it done like that, then your last step is to actually write the solution. So we'd actually, in this case, have plus 7 plus 1, which would give us 8. And then we'd have minus 7 plus 1, which would give us negative 6. So that's where we get our two solutions in this case. Okay, so we'll try another one. Oops, that's the same equation. So let's try this one. So we got a 2 in front. So same thing, isolate the squared part. So let's bring the 10 to the other side. Then we'll divide by 2. So 10 divided by 2 is 5. Now we'll square root both sides. So we actually get x plus 4 equals plus or minus square root of 5. We can't do the square root of 5. It's a decimal. So the best is just to leave it like that. So we'd actually have plus or minus root 5 minus 4. And we don't combine those two numbers because one's a root and one's a whole number. So the best thing is just leave it like that. If you actually wanted to get decimal approximations, you would go root 5 minus 4, and you'd have minus root 5 minus 4, and just figure out what those are, and that would give you the decimal approximations, which would match what you would get on your calculator. So if you actually were to do these on your calculator, as a graphing method, you would get those same decimals. So you'd get root 5 minus 4, which gives us negative 1.76. And if we do negative root 5 minus 4, that gives us negative 6.24 approximately. So those would be the decimal answers if you did it by graphing. But it's easier just leave it as square root 5 plus or minus square root 5 minus 4. That'll give you the exact answer. So the problem is what happens, like this method works well for no matter how tough the equation is. The problem is what happens if it's not in Vertex form. So if you get an equation that's in standard form like we have here, you can't use this method. So the only way you could, if you wanted to use this method, is to change it to Vertex form. So either complete the square or use the p equation. Let's do completing the square. So remember, we'd change that to half as much, so that'd be x plus 5 squared. Then we get a magic number of 25 that we need to subtract, plus we have the 24. So when we simplify this, we get x plus 5 squared minus 49. So now we can bring the 49 to the other side. And then now when we square root it, we get x plus 5 equals plus or minus 7. So we'd have 7 minus 5, which is 2. And we'll get negative 7 minus 5, which is negative 12. So it still works, you just have to convert the equation first. And just like before, we'll kind of go through some pros and cons. So the first thing is it works awesome for vertex form. Gives us the exact answers and square roots, so that's what we want, where graphing can't give us the exact answers. And what's nice about it is it's pretty fast. Doesn't matter how tough the equation is, it's pretty fast to solve. The disadvantage is if it's not in vertex form, we have to convert it. So if you're good at converting, it's a really good method to use. If not, then there might be a better solution if it's in standard form or some other version. And that's all.